Okay, so today we are going backwards from yesterday. So yesterday we went from the condensed form, one log, condensed form being one log, to the expanded form, where we have one log for every variable. Now we're going to be going backwards. We're going to be going from the expanded version, say we have a plus sign, and we're going to be multiplying them. So if we have a minus sign, we're subtracting, we're going to be dividing. So we're just going backwards. And then if there's a number out in front, as is signified right here, it's going to come up to the top and become an exponent. So here we go. Ready, Freddy. So first thing that you should deal with is these numbers out in front, or parentheses are also a good thing to deal with first, but we don't have parentheses here, so this just goes up top. So it's log base 4 of A plus log base 4 of B to the 1/2 power. Okay, it's a plus sign, so when it's a plus sign, it's always them multiplied together, this and this. So in the end, there should be one log. Okay, so we don't multiply the logs together, we multiply these values together. Okay, so this 1/2 power is great, you can leave it, but you should also recognize that we do like that better. Remember, 1/2 power is the same as the square root. So if we come over here, same idea. This 1/2 goes to the top, but this is subtraction this time. So since it's subtraction, it's always the first one goes on top, and the second one goes on the bottom. Only subtract two things at a time. Okay, and that has to deal with the whole negative exponent thing. Number logs are exponents, so when we subtract, it's division. And I don't know where the 1/4 came from. It is an imaginary crazy number, so that should be 1/2. So this is written with radicals, is that. Okay, so with a problem like this, you should do what's inside the parentheses first. So here, it's a straight subtraction. So with subtraction, it's log base 7, and we're going to divide these two. It's always the first one minus the second one, or divided by the second one. Okay, this 1/3 is on the outside, so this 1/3 being multiplied now becomes an exponent on them both. There we go. So you could have distributed that 1/3 through if you wanted, so the answer could also be, if we write it like this, could be the cubed root of A over B, or it could be the cubed root of A over the cubed root of B, because that 1/3 gets distributed to both of those exponents. It's up to you. These are all equivalent answers and all just as wonderful as the next. So we have ln's. It's an L, not an I. So these are ln's. We got to deal with what's inside the parentheses here first. So deal with those exponents that exist. 4 and 4. Remember, when we take the exponent up, we do not take the sign with it. So if there was an exponent here, we wouldn't take it there. Oh my goodness, I say too much. All right, so this is, I do this one at a time. Basically, the way I handle this when I do these is, this is an ln, so I'll put the ln there. Okay, I have 3 variables. If the ln is attached to a positive one, it should be on the top. If it's attached to a negative one, it should be on the bottom. So this is positive, so it's c to the 4th goes on top, and that's how that works. That 1/2 comes up front, so it's the ln of a to the 4th, c to the 4th over b to the 1/2 power. Again, you can distribute that 1/2 in. It's, you know, there's so many different answers to this question. So if I distribute that 1/2 in, it'll be a squared, b squared, a squared, c squared, and b to the 1/2 power, because I would distribute this 1/2 to the 4, to the 2, to the 4, 2 4s, and then to the b. So that b would be ln of a squared, b squared over radical b. Okay. All right, so just a few more that you can see and then I'll just throw out some answers. You're going to want a little practice. So there's a couple ways to do this. I'm going to do this one in an alternative way. I'm going to take the 6 and multiply it in. It's acceptable. Any of these things can be written like this. 24 times the ln of A plus 6 times the ln of B. So I distribute it in. It goes out in front when you do that. Now the parentheses are gone, so I bring these exponents to the top. So it's the ln of A to the 24th, this it is, plus the ln of B to the 6th, and now it's addition, so we just multiply them together. Multiply and we just put them together. So that might be an alternative, might be a way you guys like a little better. If there is an exponent or a number out in front here, to distribute it in first, and then it's up to you. Doesn't matter. Okay, number 6, deal with your exponents first. So we're going to take that 2, bring it up, the 5. Remember, just the 5, not the negative. All right, so this is log base c of a squared minus log base c of b to the 5th plus log base, that's a g, log base c of d to the 1/2. Now it's all not multiplication, so this is how I like to do this. Once all my exponents are gone, I like to just make one fraction here. And if it's positive, see, this is positive, so the a goes on top. This is negative, so the b to the 5th goes on the bottom. And this one's positive, so the d to the 1/2 goes on top. So rewriting this with the radical d, there you go. So you can put this all in parentheses, but it is all multiplied, so it's all put together. Okay. Why don't you try this one? See how it goes, and then I will show you my answer. Okay, with this particular one, you got a minus and then a parenthesis, so you could have distributed that negative through if you wanted to. Either way, it's going to wind up being the same thing. So the alternative, move those exponents up. It's addition, so the 1 log is written with multiplying these two together. Now this is subtraction. So this whole thing is negative, so these two values go on the bottom, and this is positive, so this one goes on top. Okay, you go, G. Okay, with this one, these two are added together, but I did distribute that 2 in first. Either way, it turns out fine and the same. So this is x winds up being x squared y to the 8th, and this is z to the 5th. These two are both positive, so when we write it with 1 log, the x squared and the y to the 8th go on top, and the negative, the z to the 5th, goes on the bottom. So it's no longer negative, it's just divided. All right, try the next one. Okay, this particular one might seem tricky to you. This ln is not, you don't distribute the ln through. That's not what happens. What happens is this whole thing is just x minus 3. It's just a value. It's like x cubed. So all that means is this, this 3 came up top, so then this is subtraction. So when we write it as 1 log, it's just the top one minus the bottom one. Yeah, pretty sneaky, sis. So the same thing happens here. I'm just going to step through this one real quick. This 2 comes up here. So it's the ln of x minus 4 plus the ln of 2x plus 5. This ln, and with the parentheses, that's not multiplication. Okay? I can't distribute the ln in. That's not how it works. So we just leave it alone. And then since this is addition, it's the ln of x minus 4 times 2x plus 5 squared. So I just take these two pieces, this one, and write it as 1 log together. Okay? All right, so try this one. It looks scary, but it's not. All right, with this one, again, it's addition, so whatever is here and whatever is here is just going to be multiplied together. It's somewhat nasty, but whatever. So this 3 comes up top. The 1/2 comes up top. We're adding them together. There's 2 logs here, so these two just get multiplied. I can't do anything with that. That's all I got. Pretty exciting, right? And then finally this one, and we'll be done. All right, then finally this one ends looking like this. This x squared This 2 goes on top and the x squared is positive, so it's on top. This is minus this whole thing. So these two get multiplied together because it's addition, but then this whole mess, it's this one goes on top and this goes on the bottom. Alrighty, we're going to say that's it. That's it. Oh yeah, there we go. See ya.